Okay, folks, in this question, we are told that there are 10 pens in a box. There are X red pens in a box. All other pens are blue. So blue pens, I can form an expression. If there are X red pens, that means there'll be 10 minus X blue pens in the box, because these two have to add to make 10, right? And that makes sense. If you're unsure, if you do X add or X plus 10 minus X, if you collect your like terms, it literally goes back to just plus 10 or just 10. It says Jack takes at random 2 pens from the box. Find an expression in terms of X for the probability that Jack takes 1 pen of each color. Okay, so give your answer in its simplest form. So I'm going to try to obviously set up here like a tree diagram actually to obviously help us here, or you don't actually need to actually do it here. So we're going to have red, we're going to have blue, we're going to have red, blue, red, blue. Okay, so we're looking for the combination of red, blue, and blue, red, right? So yeah, that is what we're looking for. So we're looking for, yeah, this tree here, obviously times by this tree here, and this tree here times by this tree here. Okay, so for red, there's going to be X out of 10, so X tenths for our red. Okay, and there's going to be 10 minus X tenths blue pens in the box. Okay, so hopefully you're happy with that. Okay, now when I take one, okay, because yeah, we're obviously not going to replace it, so we're obviously going to reduce one. So if I take X red pens, they'll now be, yeah, X over 9, right? So they're about 1 less. Okay, because think about it. So let's say, I don't know, yeah, there were 7 red here and 3 blue. And that'd be what, 7/10 red. So yeah, that then be obviously yes. Oh, sorry, yeah. Sorry, it'd be X minus 1. Sorry, yeah, over 9. Sorry, yeah, X minus 1 ninths. Okay. So yeah, think of it. If you're unsure, yeah, just change it into like some. So 7 over 10. But to take one, yeah, that's gonna go down here to 6 over 9. Okay. So yeah, if it helps you understand that, okay. But yeah, I'm just gonna leave the numbers in here just so we can see how it's gonna fit in a second. Okay, so yeah, so that is gonna be for that one. So this one is here for it to obviously add up to 1. Okay, and obviously you have to put it out of 9. Now to make this add up to obviously to 9 ninths, I'm gonna have to have 10 minus X. Okay, because that's obviously gonna stay the same. Okay, and then down here, okay, so I've taken 1 blue. Okay, so let's just put some numbers here. So let's assume here there's 7 red and 3 blue. Okay, just for argument's sake, if it's 3 blue, so that'll be 3 over 10. If I take one, it's going to go here to 2 over 9 or 2 ninths. So I'm going to have 1 minus this here. So what that'll be? That'll be X minus 9, I think, over 9. Okay, is that right? Yeah, I think it's right. Okay. Yeah, I think it's actually right. Yeah, I think it's right. I think, yeah, because you're doing like one whole, so you're doing like 10 over 10. Okay, minus. Over 9, actually, yeah, over 9, yeah. Okay. So yeah. Sorry guys, yeah, I'm just trying to think here, because this is where it gets obviously a bit actually fiddly, because I'm trying to work out. So, because yeah, I'm leaving it ever. So once I've taken 1 blue one, right, it is meant to go down here to 9 minus X over 9. Is that right? I think that's, yeah, 9 minus X ninths. Okay, is that right? Because you reduce the denominator by 1 year, so that makes sense. But you also reduce 1 year from the numerator, okay? But that is also the same as here. Yes, I'm going to write it as here. So yeah, I'm going to write it as 9 minus X ninths. Okay. And then on top here, for it to be red, okay, that is going to be what? to make it into 1, I'm going to have plus x minus 9, so x minus 9 for red. Okay, I think that's actually right, guys. I apologize if I made a mistake. I believe it should actually be right. Okay, because without numbers here, like it gets actually quite confusing, right? So like, yeah, I believe actually that's right. Actually, so now I'm going to do this times this plus this times this, right? Because it's one of each color. So we're going to have x tenths times 10 minus. So we're going to have x over 10, okay, and I'm multiplying it by 10 minus x over 9, or 10 minus x ninths. And then I'm going to add on, so I'm going to add this 2, okay. Sorry guys, yeah, if I'm not actually doing this perfectly, yeah, but yeah, it is definitely like a trickier question. Yeah, obviously worth 5 marks here for definite, okay, on a past paper. So this and this, and then plus 10 minus x tenths times by x minus 9 ninths. Okay, so yeah, we've got some multiplying fractions involving algebra. So in this first one, we're going to have x brackets here, 10 minus x, okay, on the top. Okay, so yeah, I'm going to have x lots of 10 minus x. Okay, on the bottom, 10 times 9 is 90. Okay, and then I'm going to add on, again, I'm going to have 10 times 9. Okay, shouldn't be a 2, there should be a 9. So x minus 9, yeah, over 9. So on the bottom, I'm going to have 9, 90 again. And then I have 10 minus x times x minus 9. Okay. Now, why I'm not actually expanding yet, you'll see why in a minute actually, because I'm trying to simplify it first. Okay, sorry. So now, yeah, obviously I'm adding fractions. Yes, I'm adding algebraic fractions. Okay, I've got the same denominator, so I can leave that over 90 now. Okay. I can also factor out, okay, a 10 minus x from both. So if I factor 10 minus x out of both, okay, I'm going to put like a little squared bracket, okay, like that. So times it by x, and then plus x minus 9, okay. Because if you think about it, if you're unsure, okay, sorry, I haven't got much space here, I'm going to just change. I'm going to put x over 10 here so you can see, okay. And you have x minus 9 here, okay. And let me just move it around a bit. So sorry guys, apologies about the lack of spacing. Hopefully you're obviously able to follow me. Okay, I can factor out 10 minus x from both, and then inside the bracket it's going to be x brackets x plus x minus 9, sorry. So it's going to be 10 minus x, okay, multiplied by 2x minus 9, okay, all over 90. Okay. And I'm going to say, guys, that was a nasty, grade 9 question, okay, but hopefully it made sense. Okay, and hopefully I'm not making any mistakes. I hope, okay. At the time of obviously recording this here, like late in the evening, but yeah, hopefully that makes sense. Okay, the bit for me here that obviously I'm finding obviously a bit tricky here, because without any numbers here, when you put it into the trees, I mean, it makes it obviously a bit trickier. If you reduce 10 minus x by 1, right, I assume you have 9 minus x, right? So yeah, I mean 9 minus x all over 9. Okay. So I believe, I'm pretty confident that should be our final answer. Okay. But yeah, hopefully that makes sense. Okay. So yeah, obviously expand it if you need to, but I'm not gonna bother obviously wasting time. Okay, but yeah, okay, expand it if you want to, and obviously leave your answer in the comments below. If you do expand then you may take, okay, let me know what you get, or let my audience know what you get. Yeah, obviously when you expand it, okay, or I can just say it verbally, you'll get what, 2x, sorry, minus 2x squared, um, minus 90, and then plus them in the Excel. I'm sorry, I'm being a bit lazy now in my working, but yeah, hopefully that makes sense. Okay, but definitely a grade 9 question, okay, looking at probability, okay, and yeah, hopefully you're finding this grade 9 series is quite useful. I'm trying to get focused on some harder questions now, okay, these trickier questions, okay, involving forming and solving expressions, okay, for grade 9 students.